Hi everyone, in today's lesson we're going to talk about a concept called linearization, or sometimes referred to as tangent line approximation. So what is this? A linear approximation, or a tangent line approximation, is the idea of using the equation of a tangent line to approximate values of some function f of x for some value of x near x equals a. So, this concept, linear approximation, is a very old concept that mathematicians used when calculators weren't invented. Normally, if we had the equation of this curve, all we would do is plug this curve into the y equals, figure out what x value they're asking for, and then we can find the corresponding y value. So, calculator is super easy. But if you don't have a calculator, what you can use is the fact of finding the equation of this tangent line. What you should notice is that the tangent line at x equals a corresponds to the y value that we are looking for, right? They share the same point. So if this point here is a and then f of a, we can clearly see here that this is your f of a and that this is your a. So the point a f of a, which is on the tangent line, is also on this curve. So if we write the equation of the tangent line, we can use that to approximate what the value will be of the curve at x equals a. So let's go through an example. So example number 1 here says, given f of x is equal to the square root of x, write the equation of the tangent line to f of x at x equals 1. Okay, well, we know to write the equation of a tangent line, we need two things. We need a point and we need a slope. In order to find the point, we plug into the original equation, f of x. And in order to find the slope, we plug into the derivative, f prime of x. So let's go ahead and find the point. The original function, f of x, is the square root of x. And I want to find this at x equals 1. So I'm going to plug in 1. We know the square root of 1 is 1. So this corresponds to a point, 1 comma 1. And now the slope, we need to find the derivative. It would probably be in our best interest to rewrite this as x to the 1/2. So my derivative, f prime of x, is a power rule. We take the 1/2, bring it in front, and decrease the power by 1. Remember that 1/2 minus 1, or 2/2, is negative 1/2. And now I'm going to plug in 1. So 1/2, 1 to the negative 1/2. Now remember, we don't have a calculator, so we have to remember negative exponent rules. If it's negative on the top, I can bring it to the bottom, and then it's positive. So this means 1 to the 1/2 is the square root of 1. We know a 1/2 power is a square root. So the square root of 1 is just 1, times 2 is 2. So f prime of 1 is 1/2. That is your m value. So the equation of the line is y minus y1 equals m, x minus x1. Now, we are going to use this tangent line from part A to estimate the value of f of 1.1. So let's just draw a picture so we have an idea of what's happening. So the square root of x, again, we don't have a calculator, but we should know that the square root of x starts at the origin and makes a little curve, and it looks something like this. So I want to estimate the value of f of 1.1. So that's really if I were to plug 1.1 into here. So the actual value is, if I had a calculator, I would do, so f of x we know is the square root of x, I would do f of 1.1. So if I had a calculator, I would plug in square root of 1.1 and that would be it. So what I'm going to try to do is find a tangent line that's super duper close to 1.1. So I'm going to exaggerate and I'm going to put 1 here. And I'll put 1.1 right here. We're going to use the tangent line at x equals 1 because that's a whole number really, really close to 1.1, and it'll be easy for us to find the math. So this tangent line at 1.1, or 1, excuse me, is going to be something like this. That's my tangent line. I'm going to use that to approximate 1.1. And really 1.1 is super duper close, so it's probably going to be, right here. So how close is that, right? That's a good approximation of the value of the function because it's right on there on that tangent line. So how do we do that? Let's start by using the tangent line, y minus 1 equals 1/2 x minus 1. And what we're going to do is we want to estimate 1.1. So on this line, when x is 1.1, what is y? So that means we're going to put 1.1 in for x, and we're going to solve for y. And now 1.1 minus 1 is just 0.1. And it would be helpful to know that 0.1 is 1/10. So we can change this to 1/10. And we have y minus 1 equals 1 over 20. And then we just add 1 to both sides. And remember, adding 1 is like adding 20 over 20. So 1 over 20 plus 20 over 20 is 21 over 20. So that would be my y value that would correspond closely to this 1.1. So now what I'm going to say is, I know we said we didn't have a calculator, but I would love for everyone to take out their calculators now, and I would actually like you to calculate this and see how close it is to this, and then hit resume when you're ready for the answer. Okay, so when you type in your calculator, this value, f of 1.1, gives you 1.0488 and then a whole bunch of other numbers. And if you put this in just as a decimal, you're going to get 1.05. So look how close they are. 1.05 and then 1.0488. If you rounded this 2 decimal places, it would be almost exact, right? So the idea of this approximation is that it does a really good job of approximating a value without the use of a calculator. That this is 1.05 and this is actual value is 1.0488. So this is clearly bigger than this. So we can say it's an over approximation. But you really want to look at the graph because remember, you don't have a calculator. Okay, so part C. Is the value found in part B an over approximation or an under approximation? Now, you can tell just by looking at your answers. So the graph, if we do the graph here one more time, my square root of x function looks like this, and the tangent line is completely above the function. So since the tangent line is above the function, any value that I use is going to be an over approximation. So we would say over approximation, and you can say because the tangent line is above the function. Okay, part D. Approximate f of 0.25 using the same linearization or tangent line at 1. So the line that we had before was y minus 1 equals 1/2 x minus 1. So we're going to use the same line, and we want to estimate f of 0.25. So everywhere I see an x, I'm going to put a 0.25, and then minus 1 and a 1/2. So y minus 1 equals 1/2. And 0.25 minus 1 is negative 0.75. And we know 0.75 is 1/4. So negative 1/4. And when we multiply tops with tops, bottoms with bottoms, negative 1/8. We could add 1 to both sides. And remember, adding 1 is the same thing as adding 8/8. So negative 1 plus 8/8 is 7/8. Now again, I know we are not supposed to have a calculator, but if my original function was the square root of x, can we use the calculator? Tell me what f of 0.25 is, and see how far off it is from this estimated value. Once you're ready, hit resume for the answers. Okay, so this actual value, when you plug this into the calculator, you should get just 0.5, and then when you put in 7/8, you get 0.875. So what you should notice with this problem is that zero point 0.5 and 0.875 are not as close as the last one. So this leads me to question number, or part E. Is there a better linear approximation or tangent line that you could have used to estimate 0.25? Explain, and then use that tangent line to approximate f of 0.25. So the question is that you want to ask yourself to answer part E. Why are these numbers so far apart? Remember, we're trying to estimate this value using this value. So I'm going to leave you guys to think about that, and we're going to start class tomorrow on part E. So think about it, explain it, and try to see if you can answer it. Okay, have a good night.